Hello everyone, I'm Alex Amoruso, a MATLAB Student Ambassador at Politecnico di Torino, and today I will show you an Arduino application developed by using MATLAB. This is the second video in which we present the Arduino and MATLAB combination, and if you missed the first video, you can find it in the video description right here. This time we will use a so cool sensor, an electromyography sensor, that measure the muscle activity. These kinds of sensors have traditionally been used for medical research and diagnosis of muscular disorder. So the sensor is this one, as all the components in the microcontroller applications is very small. This is in my hands, so it's very small, and enables you to connect the electrodes in order to measure directly on the muscle via these three buttons, including the reference one. The schematic for the connection is very simple, since the sensor already presents the main 3 pin, the 5 voltage, the GCC, and the signal. Concerning the sensor position, so I've chosen the forearm. The sensor has to be placed so one of the connected electrodes is in the middle of the muscle body. The other one should line in the direction of the muscle length. The reference, that is the black one, is placed on a bony part. So we can go forward with the goals of the project. So in this project, we connect Arduino correctly to MATLAB, and again, if you missed the first video, we did exactly this. So we connected Arduino. We showed how to connect Arduino, and play a little bit with a sensor and a LED. This is the first video. Today so we have to do the same thing, and after that we create a graphic user interface for a virtual actuation. This is a screenshot of how we expect from this graphic user interface. As you said, as you see, is just a matter of connecting 3 main figures: a sphere, a cylinder, and a cone. Then we need to acquire and processing the signal, and the goal is obtain a smoother and more regular signal. And then we convert the values from the signal to angles in order to reproduce the real-time actuation. So the movement will appear in this figure. So the actuation is in the sense that this cylinder, that can be viewed as an arm, a robot arm, during the movement goes from 0 degree to 90 degrees. That is obviously the movement that the forearm can do. And then finally, along with the movement of this virtual actuation, we want also to plot the signal. Okay, now let's take a look to the code and briefly comment it. The first part is more or less similar to the one that I did in the first video. In fact, I created an Arduino object. Then regarding the graphic user interface, I created a stop button and a degree label that shows in real time the angle value. Then in the visualization part, essentially I created the 3 components that are the cylinder, the sphere, and a cone, that then will be put together using the surface command. And then I created the the transform handle that will be used to move this virtual actuator according to the angle value. Then so I repeat what is the goal of this project. So essentially, my need is moving this virtual actuator according the movement of my hand and my forearm. So I the standard movement is this to this position. So the angle, the total angle is 90 degrees, and testing several times the sensor with this movement, I figured out that the range is were these ones. So starting from 0 to 1 voltage, and so I divide these ranges in map. It means that for each piece from 0 to 0.4, it is first map that it means from 0 to 30 degrees, and so on. And I created 4 maps that will be used in the get angle function in the loop when I start when the movement is started. In the get angle function, I actually measure from the sensor using the read voltage function. But firstly, I didn't want to measure one to collect one measure at a time, but I would prefer to use time a time window of 5 measurements, and I collect the 5 measurements. For each of them, I applied a first order low pass filter, so an AMA, exponential moving average, to get a smoother signal, and then I applied the RMS on these 5 measurements. So after doing that, I just applied the maps using a get value from map, that is this function that converts a value to an angle. And this is essentially what the code does. And then I open another figure that plots simply the signal obtained by the sensor. So let's run the code. There we are, the 2 figures, the virtual actuation and the signal from the EMG sensor. So if I start my movement, the figures move and until I reach my 90-degree position here. Then if I release, we have the angle equal 0 degree. Again, okay. Okay. If I keep a steady position, 90 degree, until I press stop movement. Okay, for this video it's all. I hope you enjoyed it. I show you how to create an Arduino application using MATLAB. In particular, we used an EMG sensor with a servo motor as actuator. I leave you with the links to our Facebook and Instagram pages, where we share contents about the MATLAB world, and I wait you for the next video here in our YouTube channel.